So I think the focus of today's office hours, despite the potentially ongoing technical difficulties, is the next storm, which kind of looked like a minor event to begin with late last week and has really morphed into something once again more significant, particularly for Central and Southern California. So this is going to be yet another challenging event. Probably not an extreme storm individually by historical standards, but once again, another significant event that, on top of everything that has come before, is going to cause some major problems. It's also causing some real headaches for meteorologists because it's really rapidly, the forecast has rapidly evolved over the past few days, from something that was going to be a fairly non-consequential event to something that might have been a significant storm for the southern third of California, but not so much for the rest of the state, and now something that looks pretty significant all the way from the San Francisco Bay Area southward. So this includes now a lot of the recently hard-hit areas in the more central part of the state. So why is there so much uncertainty, and what kind of impacts might there be? Well, the challenge is, in this case, there is a jet streak off the coast of California. I've often had folks ask me from blog posts whether jet streak is a typo, and I actually meant jet stream, but in almost all cases, no. Jet streak is a localized region where the jet stream is stronger than where it is in adjacent areas. And the reason why you have to watch out for jet streaks, these isolated pockets of relatively more intense upper atmospheric winds, is that they can induce wind patterns that encourage upward motion of air if they have the right curvature and you're in the right position relative to the jet streak. And in this case, California is going to be just upstream of a strong trough offshore that is co-located with just such a jet streak. In fact, we're going to be in the left exit region of the said jet streak, which happens to be a region that is favorable for upper level divergence. Divergence meaning outward moving air from the center. And of course, if air is moving outward from the center at the upper levels of the atmosphere, you can't really create a vacuum in the atmosphere. And so where is the atmospheric mass? Where is the air going to come from to fill the void? Well, it's going to come from below. And so that is how you induce the upward motion, the vertical circulation in the atmosphere, from a horizontal atmospheric circulation feature, this jet streak. And because that favorable region for rising air will be located right off the coast of California, in fact, just 100 miles or so south-southwest of San Francisco by tomorrow afternoon, this is a region where there's going to be the potential for rapid development of low-pressure system. And in this case, there will be a low-pressure system nearby that can take advantage of this favorable environment for strengthening. The challenge is this is really down to fine-scale details, and if this sounds really technical, it is. And this is precisely the challenge, is getting this exact setup and configuration right, and pinpointing where it's going to happen has made all the difference. And in this case, all of these favorable conditions have converged closer to the coast of California. So now it appears that this low-pressure system, rather than being a pretty weak one, could rapidly strengthen overnight tonight into tomorrow. In fact, it could strengthen from about 1,000 millibar low-pressure system to one that's as low as about 980 or 982 millibars. So that's potentially on the order of 20 millibars. Millibars, of course, being a measure of barometric pressure over about a 24-hour period. We've heard in recent years about all of the colorful news headlines about quote-unquote bomb cyclones, which actually does refer to a real meteorological term called bombogenesis, which is surprisingly quantitative. It refers to a drop in the barometric pressure of a low-pressure system by 24 or more millibars in a 24-hour period. So it's actually a very precise quantitative definition. Well, as I just mentioned, this low-pressure system might come pretty close to that bombogenesis benchmark. Might not quite reach it, but the point being, this is going to be an unusually rapidly strengthening low-pressure system. That doesn't usually happen very often off the coast of California. It's not a favorable region, even during storm season, for storms to rapidly strengthen near the coast. And when they do so, that has historically been a signal for storms that end up having worse than initially anticipated impacts or relatively severe impacts overall. And so this is a somewhat unusual development. It's not that surprising given where the jet stream is, and we did see this event occur earlier this winter farther from the coast, though. The interesting part here is this rapid cyclogenesis, which is another sort of more meteorological sounding term for bombogenesis of a certain magnitude, is going to occur right off the coast of San Francisco Bay Area. And so what does this mean? It does not necessarily mean that the San Francisco Bay Area is going to see the strongest impacts from the storm, because often the strongest effects of a cyclonic storm of any kind, whether they're a normal winter storm or a hurricane or anything like that, is often in the front right quadrant. In other words, in the northern hemisphere, in the southeastern quadrant of the storm. And in this case, that quadrant is going to be more squarely over the central coast and southern California. So even though the center of this deep low pressure system will be very possibly right near or even over San Francisco by later Tuesday into Wednesday, the strongest winds and the heaviest rain will likely occur south of San Francisco, right around the Monterey Bay Area southward, maybe into Santa Barbara or Ventura counties, with heavy rain impacts and heavy snow impacts at very high elevations all the way south to the Mexican border. So this is not going to be a very high impact storm for the northern third of California, but it very well may be for the southern two-thirds of the state, and that may include parts of the San Francisco or Monterey Bay areas, but probably not too far north of there. What kind of impacts are we talking about? Well, obviously it's going to rain more. The heaviest rain will be associated with a weak to moderate atmospheric river, maybe with some embedded isolated thunderstorms over southern California. So we're talking maybe Ventura, Los Angeles County southward for the heaviest rains. There won't be an atmospheric river with this event in northern California. However, Northern California or Central California will be affected by the low pressure system itself, and that has the potential to generate some very strong winds. Once again, I know parts of the Bay Area are actually still recovering from what was a historically significant windstorm just last week. Well, this didn't look like it a few days ago, but now it looks like it might actually end up producing yet more strong winds, probably focused on a slightly different part of the state, maybe 50 to 100 miles south of the maximum winds last time, but there's still going to be some overlap, particularly in, say, Monterey County and the southern part of the San Francisco Bay Area, where there could be strong winds once again. And there's also really high uncertainty regarding just how much this low deepens and just where it ends up making landfall. There are some indications it might just sit around San Francisco and spin there for like a 24-hour period without moving very much. If that happens, breezy to windy conditions in the Bay Area and very windy conditions south of the Bay Area, potentially damaging winds south of the Bay Area, may last for a prolonged period of time and shift direction as this low just sort of meanders around for a while. So that could compound damage. Also, the rain in central California, which includes the San Francisco Bay Area and the Central Coast, will be heavier with the storm than initially anticipated. It's still going to be a relatively cold storm up north, so we don't expect to see rain at 8,000 feet in the Sierra with this one. I don't think this is going to be a huge snowmelt type event. But in its own right, it might produce more heavy snowfall in the central and southern Sierra that are already seeing record snowpacks. That's going to be disruptive. It's going to produce certainly widespread light to moderate rainfall as far north as the Bay Area, and maybe locally heavy rainfall. And this is where there's some big caveats, since if the low stalls out for a day or two near or over the Bay Area, there may be some localized area where it just rains incessantly for like a 36-hour period. And it may not be extremely heavy rainfall, but it could be moderate to occasionally heavy rainfall, and it could be sustained over a prolonged period of time. You probably can guess where I'm going with this, because everything is already so saturated. That could be a problem from a flood and a landslide perspective once again. This is a storm that I don't know exactly what's going to happen. There could be some major wind impacts, especially along the central coast, but maybe as far north as the southern half of the San Francisco Bay Area. The heaviest rain is definitely going to be in Southern California, and LA and San Diego will both probably see more rain out of this storm than a lot of other storms this winter, because it is, again, that weak to moderate atmospheric river will be focused on the southern third of the state primarily. But then Central California, and by Central California I mean all the way up to right around the I-80 corridor on the northern end, is going to see potentially widespread significant rainfall and locally significant winds once again out of this, and maybe some more thunderstorm activity, which again, even if it's isolated, can produce isolated flash flooding or more significant flood concerns. So this is going to bring a whole litany of concerns that are probably greater than I had initially anticipated a few days ago. This again looked like a pretty weak storm to start, but now looks less weak and looks like it's going to have a more widespread impact and farther north. Exactly how far north remains to be seen. How significant the impacts remains to be seen. This doesn't look like an extreme rainfall event anywhere. I will say this. It looks like most places in California will see less than 2 inches of rain from this, although locally there could be places that see 2, 3, 4 inches of rain. So not an enormous rainmaker, but the problem is there could be localized totals higher than that, so on some localized mountain peaks, especially if there's a band of precipitation near the low center, or part of a trailing thunderstorm band on the outer fringes of the system that just sits over the same place for a while. That could cause some problems. And frankly, even widespread moderate rain at this point is going to exacerbate flood conditions in some places. So not the best news. I think meteorologists are very tired of this winter in California. It's gotten pretty exhausting, especially this week, to look at every model run in the storm looks different and slightly worse than the last. So again, it's arriving tomorrow, but it may linger into Wednesday because it looks like it might just sit around the Bay Area for a while. So the storm has higher potential to produce wind-related damage and higher potential to produce some flood impacts than originally anticipated, and across a broader region. Heaviest rain, Southern California. Strongest winds, Central California. Possibly partially overlapping with the strong winds from last week, but mainly south of that region for now, although this storm has very high uncertainty associated with it because it may, quote-unquote, bomb out, rapidly deepen low-pressure system due to favorable atmospheric conditions, and it's often really hard to predict exactly how much it's going to deepen and exactly where it's going to end up if it does so. So there's a wide range of outcomes that could still happen, even though this is only 24 hours in the future, but I do generally expect the impacts to be greater than we thought a day or two ago. So that's the deal with this storm. I'll follow it on Twitter. I don't have time to write up a formal blog post, unfortunately. There's just too much else going on. But I may follow up with another office hour later this week, depending on how things go. Some broader context around the state. Again, as we talked about last time, the southern Sierra Nevada has now experienced a record snow season. There is more snow water equivalent up there in the southern Sierra than at any point in at least since the 1950s in the formally recorded record, and likely longer than that. We just don't have a complete record everywhere. Central Sierra is almost there. It's a record for the date, and it may shortly be a record for, again, any calendar date as we continue to add to that snowpack. So, again, the storms this week are not going to melt the snowpack. They're actually going to further add to it. We're going to have an even larger snowpack at the end of this week than we did at the beginning of the week. These are pretty cold storms in central and northern California. Not exceptionally cold like the ones we saw earlier this winter, but cold enough to produce mostly snow at most mountain elevations in northern California. So we're going to see even more of the white stuff on top of the tens of feet that have already fallen in some places this winter. Downhill, though, at lower elevations, again, not causing huge snowmelt, but at a certain point, we're having problems even from rain at lower elevations. This is going to be particularly true in the Salinas Valley, the Pajaro River. The levee breach there, I believe, has been patched, but if things are still tenuous, there's a lot of agricultural areas that are still flooded residually. This could make it worse. There could be additional levee failures. That's not a prediction, but it's just a reflection on the state of the system. Is clearly not great, and so we're at the point where we're stressing it. But I do think the greatest flood concerns, aside from the localized flash flood concerns in Southern California with this event, again remain in the southern San Joaquin Valley. Even though the heaviest precipitation will not be centered there, any precipitation at this point is going to be a problem because we're getting sunny day flooding now from all the water flowing out of the southern Sierra. Many of you may have heard the anecdotes that continue to emerge about what's going on in the Tulare Lake watershed, and in particular the former Tulare Lake basin in the valley itself, which is rapidly filling up with water. And the water wars became a little more literal over the weekend when there's some stories of subterfuge and 2 a.m. heavy machinery to secretly bulldoze levees in the dark of night so that someone's land might not flood at the expense of other people's land, and also notably at the expense of low-income agricultural communities. And so there is an ongoing battle, I think it's fair to call it, in this region right now. There are a lot of players. There's local, state, and federal authority on different parts of the water in this system. There are agricultural interests. There are people who live in the area in small communities. So Tulare Lake Basin right now is the epicenter of this fight. But I think, unfortunately, it's going to expand because the flows are going to continue to increase. They're going to remain high. We keep hearing about episodic levee failures on agricultural levees and creek levees, not so much the primary flood protection levees along the major rivers like the San Joaquin and the Merced River, but on smaller tributaries to them, have been levee failures. There will be more levee failures. And to be quite honest, there is a very high level of concern regarding what may face the broader San Joaquin River watershed, the whole system, and its flood control capacity. We now have the San Joaquin River at Vernalis, one forecast point from the California Nevada River Forecast Center, is forecast to go above flood stage and stay actually above danger stage, which is a step above flood stage, indefinitely. Now, to be clear, this does not mean that there is a high likelihood, imminent likelihood of severe widespread flooding, even given that prediction, because the levees in that area are designed to accommodate these flows and even higher flows. This will not be the highest flow recorded at that forecast point. It won't even be the highest flow in the past 20 years. But the problem is not the absolute magnitude of the peak, but its duration. And the reason why danger stage is relevant is it doesn't necessarily mean that it's dangerous flooding occurring, but what it means is that river levels are high enough that they are past the design capacity of certain critical flood control system components. This may mean that levees are stressed, meaning that there is more water for a longer period of time than they were really designed to handle. The reason why this is important is it means that the longer that rivers persist near or above danger stage, as is increasingly the case in the San Joaquin system and will be the case probably for weeks to come, is the likelihood that levees fail, either gradually or even catastrophically, increases with time. So the longer the duration of this very high flow period, the longer these forecast points spend above danger stage, the higher likelihood there is that something goes wrong. And no one, frankly, can predict exactly where things might go wrong or how severe the consequences would be. But I think most folks in the water world do agree that the longer this goes on for, the larger the potential for major problems to develop down the road. And the problem is, of course, we're not even really seeing the effects of the melted snowpack yet in any substantial form. 98% of what's up there is still up there, stored in the snow water. All the problems we've seen recently is either directly from rainfall or from the relatively limited amount of snowmelt that occurred comparative to how much snow is still up there from the warm storms of the last 10 days leading up to this. So, unfortunately, this is a problem that is going to get worse before it gets better. And I don't know how much worse it's going to get, but it's already pretty serious in some places. In communities on the tributaries to the San Joaquin River in the southern Sierra watershed, in the foothills, and then especially increasingly in the valley, Tulare Lake Basin in particular. So this is going to be potentially pretty dramatic story to be following in the weeks to come. Really, I don't think we're going to see peak flows on the San Joaquin system until maybe April. Sometime in April would be my guess, although honestly, I don't know. There's so much water up there, it might take until early May to really get going, or it could suddenly happen sooner than that, although I guess at this point, I don't see any likelihood of really major melt events in the next 10 days, so I guess that does pretty much get us to April at this point. So it'll probably be April as the month of reckoning with this gigantic snowpack that's eventually gonna melt and flow downhill It's a question of how quickly it flows downhill. If it's gradually, originally I was saying if it's gradually, we might get lucky and only see minor flooding. I think at this point we're already past minor flooding in some places, and so best case scenario is it stays manageable and we only see kind of moderate flooding in a limited capacity. But the potential is there for major flooding, for serious flooding, especially if the flood control system is taxed, especially if there are any failures on any levees, of course, can be a problem, but in particular, the main levees, the primary flood protection and life protection levees along, say, the San Joaquin River, could really be taxed with this long duration high flow period. So I'm not a hydrologist, but I do speak, I am essentially constantly talking with folks at the Department of Water Resources, the Bureau of Reclamation, Army Corps of Engineers, so I do have a sort of a general sense of what the consensus seemed to be, and the consensus is that there's just so much water stored up there in the snowpack, and we're already seeing flood issues that, unfortunately, the likelihood that it gets worse before better is almost 100% at this point. It's just a question of how much worse it gets before things improve late spring and early summer eventually. So I'll leave it at that for now, since there's not a whole lot of new information today coming out of that region. But there, this has sort of been a slow unfolding emergency there in recent days. I'm going to start looking at some questions, since I spent a little bit more time than I had hoped at the beginning dealing with the technical difficulties, although those seem to have mostly resolved by now, so that's good. Let's see here. So let me just scroll back to the beginning of comments here. Yeah, a lot of comments about audio and video, but I think it's coming through better now. Question from Rachel Ramirez. Can you quantify what number this storm will be for the year and season? Is this amount in quick succession normal or rare? Can you characterize? I don't have the exact numbers, and honestly, it depends a lot on how you quantify storm, or even if you restrict this question to how many atmospheric rivers have there been in California this year. I know that Scripps keeps track of this, but I think there's a bit of a public communication challenge here because, many, by formal definitions, most significant winter rain events in California are associated with at least a weak atmospheric river. I guess the question is, how meaningful is it to count weak atmospheric rivers as atmospheric rivers? There's still a bit of a debate in meteorological circles whether their atmospheric rivers are truly distinct in all of their forms from just the ordinary warm sector of a mid-latitude winter storm, mid-latitude cyclone. And I can see that argument. I do think that there are certainly some atmospheric rivers that are clearly distinct from that. And these would often be the really pronounced Pineapple Express type atmospheric rivers. Like we've seen a few of them this winter where they extend, way beyond the parent low pressure system itself, sometimes by thousands of miles, and sort of exist coherently even in the absence of a parent low pressure system. So there are definitely, I would say with certainty that there are some atmospheric rivers that are clearly distinct from just being part of the warm conveyor belt of a mid-latitude cyclone would be the technical term that some meteorologists prefer to use. But there are some that are sort of closer to being like on the cusp of, is this really distinct from the low pressure system, or is this kind of just a function of the fact that we have a low pressure system and there is, on the southeastern flank of a low pressure system in the northern hemisphere, you're going to get warm and moist air drawn into the spinning wind circulation. That's a fair argument. So it's a long way of saying it's difficult to quantify. Scripps will give you a specific number because essentially they have an algorithm that calculates atmospheric rivers. The formal definition, I think, is how many times have there been long and sinuous moisture transport corridors, which the core of the corridor exceeds 250 kilograms per meter per second in the cross-sectional area. It's a very specific definition. The point being, though, qualitatively, there have been a lot of atmospheric rivers and also a lot of non-atmospheric river storms in California this winter. So there have been a lot of them, no matter how you slice it, no matter how you make these formal definitions. And yes, this is unusually many. We've now had at least 3 major storm cycles this season, and they've each been fairly exceptional in their own right for somewhat different reasons, but they've each been significant both in terms of rain and wind-related impacts, and now increasingly snow-related impacts as well. So this is an unusually high number of storms this winter in California. I think that's certainly safe to say. We've seen a jet stream that's been unusually active and extended unusually far to the east, closer to California, so it's been stronger, more eastward extended across the Pacific than is usual, certainly more so than is usual during a nominal La Nina winter, although I guess it is worth mentioning La Nina is now officially out of here. It is gone. It is no longer in effect. La Nina has disappeared in the tropical Pacific Ocean and has rapidly been replaced with rapidly warming ocean surface temperatures. So a precursor to El Nino, we're not there yet. We do not currently have El Nino conditions in place. I don't think we can attribute anything we're currently seeing to El Nino or El Nino-like conditions even yet, but it's pretty clear that's where we're headed later this summer and fall. So I'll talk about more about that later. But in terms of the succession of storms, all I can say is that we are lucky that we have gotten some breaks in between these storm cycles. As much as folks feel like it's been an unrelenting winter, we actually have gotten some at least week-long breaks, and in some cases multi-week-long breaks in between these sequences. I will say this, had we had this winter and everything had happened back to back to back without any breaks between these storm cycles at all, the level of flooding and the level of damage in California would be, I would think, dramatically higher. So we're lucky we got the breaks that we did. For as significant as the flooding and the impacts have been, it actually could have been a lot worse if they happened in quick succession. And for folks asking about a comparison to Arc Storm, that's kind of what the Arc Storm scenario is what happens if we get a storm sequences like this, but they happen all at once. Like we just go from the December sequence into the January sequence into the February sequence with no breaks longer than 2 or 3 days in between any of them. The other difference is that we haven't seen any extreme to exceptional atmospheric rivers this year. Believe it or not, we've seen moderate to strong atmospheric rivers, but we really haven't seen any extreme to exceptional ones at the upper end of what's plausible. And so in the Arc Storm scenario, we kind of have the storms that we've had this winter mainly, but with a couple of exceptional events added on top of it. So imagine if the strongest storms of this winter had been 30 or 40% stronger, and then they had all happened right in a row. That's kind of what our Arc Storm scenarios look like. And so I'm glad we didn't get there this year, but, we definitely saw shades of it, and we came closer than I would have expected to come this year, which, well, there's a lot of things that we can say in retrospect about that, and we can talk about those a little more later. But I do think it is instructive to think about, okay, well, what if all the precipitation we had this winter happened over an even shorter period? So in other words, what if it was even more intense? And what if the most intense storm spikes within that compressed storm cycle were even higher than what we've seen this year? That's sort of just as a food for thought, matter of perspective there. All right, I'm gonna keep scrolling down here. Question from Billy is: do you think this is going to impact SLO and Santa Barbara arrivals tomorrow evening? I'm guessing talking about air traffic. Yes, very very possibly. That's right in the window and right in the location where looks like there's going to be some major storm-related impacts, rain and wind probably. So always an issue with the smaller airports in particular. A question from Noah: do you think the spring high tide tomorrow around 3 p.m. will come into play with respect to flooding near the mouths of coastal rivers? That's a good question. I actually don't know how high the tides are going to be tomorrow. One reason I bring that up is if they're going to be especially high, there is going to be really low pressure near the San Francisco Bay Area. So for like the Monterey Bay Area and the southern half of the San Francisco Bay Area, the ocean level will be a little bit higher than usual because you get low pressure in the atmosphere, and that tends to result in a very small storm surge, kind of like in a hurricane. Now again, this is not a hurricane force system. Storm surge will be nowhere near as big as you get in like a hurricane in Florida or something, but on the order of a foot or so. That won't help any flooding with coastal rivers. If there's a bit of additional If there are waves on top of that from strong winds, that can exacerbate coastal flooding. So there may be a bit of an elevated coastal flood threat for these reasons tomorrow from about, Santa Cruz County southward, perhaps, something like that, into the Southern California bight, where the coastline shifts to being more east-west along the transverse ranges along the central coast near Santa Barbara. So maybe in that portion of the coast there could be some coastal flooding problems tomorrow. Let's see here. Is this the end of it? I'm assuming this means, is this the end of the storm cycle? Right now, unfortunately, probably not. It looks like there's more to come. Again, it doesn't look like there's any huge storms after this one, but that's kind of what I said last week, and then this one looks more significant for tomorrow already. So it's an active enough pattern that there could be storms that surprise us. It still, again, doesn't look like an exceptionally wet period. In fact, I would argue that in some parts of northern and central California, the precipitation that falls tomorrow will be about as much as the precipitation that falls in the 10 to 15 days that follow. So hopefully that helps. But there could be quite a bit of precipitation tomorrow, and there could be, so you double that over the course of 16 days. And again, it's not huge, but it's not nothing either, given there's already been so much water, there's ongoing flood issues. So I do think the storm cycle will slowly wind down. I mean, we are getting close to April, but I don't think it's going to go away. It looks like unsettled conditions, relatively cold conditions, additional snow accumulation, additional rainfall, lower elevations are going to keep happening. I don't see any big heat waves on the horizon, which I guess is sort of good news in the short term, just from a flood risk and a snowmelt perspective. But what it does mean is that we're going to keep accumulating snow, and what I'm increasingly concerned about is that now, if things remain pretty cool into early April, the likelihood that we very suddenly transition from cold conditions to much warmer conditions increases the longer we go into April and things stay cool. The more likely it is that things suddenly get pretty warm the later in the season we get. So that's the big concern, I think, moving forward. We'll just have to see how that evolves. Just reading some more comments here. All right, some reflection that the highest tides this week were Saturday, Sunday. That the Tuesday tide swing is above average but not extreme. So I don't think there'll be any massive coastal flooding. But any high tide combined with a bit of a storm surge from winds and low pressure plus runoff coastal rivers from rain can result in some problems. So we'll see how that goes. I don't think it'll be as bad as like the late December coastal flooding, say, in the Bay Area. But again, the storm is tricky and it's changing at the last minute. So I would definitely keep an eye on the forecast in case things come in on the really high end of what's plausible. Let's see here. Oh yeah, this is a good question, and I am from Mountain Kimmy. Can we anticipate more frequent or intense convective activity? Convective activity meaning thunderstorms, essentially, in the Central Valley, like the supercell we saw last week. There were actually a number of supercell thunderstorms last week in the Central Valley that were individually pretty exceptional in their own right. They looked like something out of the Great Plains, and a couple of them did produce tornadoes and large hail and flash flooding. So they did produce the kinds of impacts that you'd get from a Great Plains supercell thunderstorm too. They were unusually pronounced for California. They were really visually dramatic, and they occurred in the warm sector, which is a little bit unusual. Air temperatures were in the 60s and even low 70s in the Central Valley when these occurred. So, these were not particularly cool conditions. This was warm, moist, buoyant air, sort of in that in-between atmospheric rivers phase. And that is a favorable environment for convective instability to produce strong to severe thunderstorms, although it's kind of unusual for it to happen in California. But the bigger question is, in a warming climate, should we expect more of this, especially in the Central Valley? And there's not really much formal literature on this that's California specific, but I'm going to go out on a limb and say yes, that is plausible. I think it's significantly more likely than not at this point, because really what we find is that globally there's a growing consensus that in a warming climate, the convective available potential energy increases almost everywhere. That's the acronym for that is CAPE. And CAPE isn't everything. You obviously need significant instability or CAPE to have severe thunderstorms, but it's a necessary but not sufficient condition. You also need things like vertical wind shear and an environment that's otherwise favorable for rotating updrafts to occur. And those things will always be unusual in California, although not extremely rare. So you do occasionally get environments that are favorable for rotating updrafts, but often you just don't have enough instability to quote unquote take advantage of it in California. So if a warming climate raises CAPE almost everywhere, then it would stand to reason that on those occasional events in California where you do have an environment that's favorable for otherwise favorable for supercells, that if you just incrementally increase the convective available potential energy, or the CAPE, with each passing degree of warming, that you might actually see more environments that actually produce severe thunderstorms. So no one's really done a formal study on this yet in California. It's kind of at the cutting edge of science. It's a bit speculative, but my speculation is that the answer is yes. That it's never going to become common. It's not like California is going to become the new Kansas or anything, but to the extent that there is already occasional risk of severe thunderstorms, especially in the Central Valley of California, but occasionally elsewhere, that will likely increase in a warming climate. That's my current personal prediction anyway. All right. Well, I may cut this one a little bit short, but maybe because I kind of want to have another one of these maybe on Wednesday or something like that to see how this storm is going and what's next. So stay tuned. I'm not committing to anything yet, but there may be another one of these later this week. Please do feel free to tune in then. Again, the storm tomorrow may end up coming in stronger and a bit farther north than earlier expected, so the impact to the central coast will be greater, and maybe even parts of the San Francisco Bay Area. It looks like the Monterey Bay Area might be hit pretty hard again, yet again. And the storm is going to kind of stall out near San Francisco, so there may be some larger than expected impacts in the Bay Area again. Again, not necessarily an extreme storm in its own right, but it's the context. The antecedent conditions are so wet, it's been so windy, that the cumulative effects of this are going to be greater than they would be otherwise. So stay tuned, and thanks for watching, and I'll talk to you all next time.